So, tell your neighbor how an object that is initially moving will move if the forces are balanced, meaning if the sum of the forces are equal to 0. So you have a moving object, and the sum of the forces are equal to 0, the net force is equal to 0. How will it move? With the fact that there's total force is equal to 0. Okay, see if you can modify, you can update, say, Newton's first law of motion, but incorporating the sum of the forces are equal to 0, or the net force is equal to 0, or the total force is equal to 0. Okay, hopefully it sounded something like an object at rest will stay at rest, an object in motion will stay in motion if the net force is equal to 0, or the sum of the forces are equal to 0. You all right with that? Okay. So what would happen if the sum of the forces are not equal to 0? Tell your neighbor. What would happen? What would happen if the sum of the forces are not equal to 0? What will happen to the motion? Correct answer should incorporate acceleration. Okay. What happens if the net force is in the opposite way the object is already moving? What will happen? How would you describe the motion of the object if it's already moving and the net force acts in the opposite direction it's moving? Tell your neighbor. Going to slow down initially. Good with that? Okay. So, one of the misconceptions that the Sletter thing wants to address, you got it in experiment or scenario 2, you got it moving and then you turned off the rockets, but there's no friction. How did it move? It kept on going. It slowed down, kept going, or kept on going at a constant velocity? Kept on going at a constant velocity. Why? Inertia. Wanted to. Good with that? Okay. How does the direction of the net force compare to the direction of acceleration? Tell your neighbor. Your choices are the same, opposite, depends on the scenario. Okay. Correct answer is the same. Always. Why? conceptually because the net force causes acceleration. Okay, mathematically, does mass have direction? No. Does acceleration have direction? Yes. Does force have direction? So mathematically, these have to have the same direction. This is mass is just a positive value always. Doesn't have direction. Good with that? Okay. All right. Give that question a shot. Tell your neighbor. Correct answer is Mack truck. Why? Because inertia is 100% determined by the mass. Does not matter about the motion. The motion is so inertia is the object's natural tendency to maintain its present state of motion. The more mass it has, the greater the tendency is to maintain whatever motion it has. You all right with that? So one thing that people get confused with is inertia is not momentum. We'll talk about momentum later. Here, the Volkswagen Bug has more momentum because it's moving. But Mack truck, because it has more mass, and only because it has more mass, has more inertia. Brandon. Great question. It does not. So what we use to measure inertia is just the mass. Tell your neighbor. Correct answer is B. Okay, it's moving from person on the sidewalk. The books are inside your car are moving. When you slam on the brakes to stop, They want to continue moving. Good with that? If you don't have a reference point to like in a plane or a really fast car, another experience is like amusement park ride or roller coaster. That not one of the not one of those, but one of those like hang on, like just shoots you. One of those. That's you can reference that. Tell your neighbor. Correct answer is I got 1 vote, 2 votes for E. E is correct. Every elephant. Anyway, you get adverb for E. Anyway, elementary elephants. There it goes. Okay, so this feeling is largely determined by your guts. Like your organs in your body have some sloshiness to them. Think about like holding a water balloon and speeding up the water balloon. Like there's some like okay, your the guts want to maintain whatever motion it's doing. So the feelings that you have, this tells you that your inertia is not doing what it wants to do. Like anytime you feel like or what, like those weird, okay, that's saying that there's things on the outside acting on your body, making you do something that your inertia doesn't want to do. Okay, so the next time you're driving, like pay attention to that. You're like, I wonder what my inertia wants to do. Okay, so this is why you feel pushed back in your seat. You're like, because your body wants to stay at rest. Like, it wants to stay there, but the back of the seat is connected to the plane is pushing you forward. Because if it didn't push you forward, you'd end up on the runway. I mean, that would be a really weird plane, but is that you see what like the back of the chair is pushing you to keep up with the airplane. Good with that? Great question. So if you were standing on ice, you wouldn't be able to do that. But friction, you go with that, and you're leaning it like you're ready for it. Because if you just stood there and the plane took off, you're like, whoa! Give that one a shot. Tell your neighbor. Correct answer is A. This is going with scenario number 2 on the rocket sledder. You turn off all the rockets after it's moving, and it'll continue moving at that same velocity. No extra force required. Okay, so I've hammered this quite a few times. Inertia is not a force. Can an object have or possess mass? Like, oh, that has a lot of mass. Is that a valid statement? Yes. Like you can say, so something has mass, something because it has mass can have inertia. Okay. But it is incorrect to say something has a lot of force. You can say something exerts a lot of force, but you cannot say something has or possesses or contains a lot. Like, wow, they got a lot of force. Like that is not a good, like something doesn't have innately in them. Force is something from the outside. Like the fist can exert force, it doesn't have force. It's a subtle difference, but just kind of tweaking that, your understanding of what force is and what it isn't. Okay. Tell your neighbor. Have a conversation.
They tried to send me home as at work, and I got there. She's like, "Let's get all your business done." Okay, so I would have been
Correct answer is. Correct answer is B. Correct answer is B. This is a special case for this. Okay. If your net force is equal to 0, then that's equal to mass times acceleration. You're not getting rid of your mass. You still have mass. So that means what else has to be 0? Acceleration is 0. That's from a mathematical point of view. Okay. Practically speaking, is it possible for you to drive your car with a constant velocity? So, in other words, at a constant speed in a straight line path. Is that possible? Not for like ever, but for a period of time. Is that possible? I really hope so. You're on a straight piece of road with your cruise control on. Okay. Is there still areas like is there air resistance present? In reality, yep. So how is it that you're able to go at a constant speed? Your engine has to make up for that. So the total force is equal to 0. Good with that? Okay. This is a really important factoid. Okay. Tell your neighbor. Tell them why you think so. Correct answer is, oops, sorry. Correct answer is D. This is getting at scenario number 1 on the rocket sledder. When will it ever reach maximum speed? Minute. Okay. Here's like the full on, okay, free body diagram. You have applied force, normal force, gravity. So in the x direction, sum of the forces is equal to mass times acceleration in the x direction. You okay with that? You only have one force going on in the x direction, so that's 50 newtons. 50 kilograms times acceleration. That's where the 1 came from. Good with that? Okay, next question. Tell your neighbor. Tell them why.
So you can't even think of the question.
Yeah. I was gonna.
I think she was behind us. Because her project wasn't there. And like, I think either broke. That person saw her like doing this. All the only people that didn't have the project behind. I think it might because they thought they were about that.
The correct answer is okay. Ready for this? That's a really important detail right there. If something is moving at a constant velocity, you know what? You know that the net force is 0. Okay? Hear me on this one. If you have a constant velocity, I do not care what the scenario is in terms of what forces are acting on it. You know that you know that you know that the net force is equal to 0. Because if it wasn't, then this would be accelerating. You'd experience acceleration. You'd be speeding up, slowing down, doing something. Okay? So your free body diagram looks like this. You have gravity, normal force, applied force, friction. Okay? Is everybody, I'm going to say something. We'll see how it hits you. Are you okay with the fact, kind of like projectile motion, that vertical forces don't affect horizontal? Horizontal forces don't affect vertical. You okay with that? Okay. So these two cancel each other out. Here we have 10 newtons here. In order for this to be true, there need to be 10 newtons on applied force. Because if this was 11, what would happen to the box? There would be acceleration. The sum of the forces would not be equal to 0. It would be doing not what inertia wants to do. Okay? If you have a constant velocity, it's doing what inertia wants to do. I will often say, is inertia happy? Is it satisfied? Is it doing what it wants to do? Yes, it's moving at a constant velocity. Therefore, you know the net force is equal to 0, regardless of what your free body diagram says. Okay? You can take that to the bank. That is huge. Good at that? So here's your scenario. You start, the fish weighs 15 newtons. Therefore, your tension also is 15 newtons initially. It's at rest. Then you get it going, you speed it up. But once you get it moving, then you just reel it so that the fish is coming up at a constant velocity. How much tension is there now when it's moving at a constant velocity? Tell your neighbor. Tell them why.
Just like constant acceleration. Just anyone ever told you that I live right?
Oh,
Like this.
fishing. The fish scared me.
Correct answer is B. Folks, this is an identical situation, identical concept to this question. Different scenario, but the exact same concept. See, I can take a, like same concept and pitch it to you in a lot of different ways. Okay, you have to own that. Okay, good. All right, the rest time is yours. Work on that lab. Did I tell you about these? I told you about those equations, right? Okay.